In the previous video, we learned that how to transfer this impedance on the secondary side to the primary side. We call that as reflected impedance. Here, the given values are, the mutual inductance and L1 and L2. So what we did there, so here is the given source R1, convert this into frequency domain, so j omega L1. Now the whole thing we converted into reflected impedance. Okay, this is ZR. ZR equal to omega square m square over R2 plus j omega L2 plus ZL, load impedance. Okay, so this reflected impedance is nothing but secondary impedance looking from the primary side or transferring after the primary side. Now, what if I don't have the M? Instead of M, I have transformer ratio. Okay, so here is ideal transformer. Okay, so here he gave us the transformer ratio. Now, how do we transfer this impedance to the primary side? Remember, this is also ideal transformer. Okay, and at the same time the dots are not going to come into the picture because you are squaring it. Okay, the M square, so mutual inductance is you're squaring it, so the dots are not going to be come into the picture. Same thing happens here too. The dots are not going to come into the picture, but I'll talk about it in a second. Here I'm assuming it's an ideal transformer. We know that S, ideal means P1 power supplied by the source is same as power received by the load. There are no power losses. That's what the ideal indicates. Okay, so for ideal transformer, I'm taking P1 equal to P2. P1 is nothing but V1 I1 cos theta 1 and P2 equal to V2 I2 cos theta 2. Okay, here cos theta 1 and cos theta 2 are same in ideal case. Even in practical case, cos theta 1 and cos theta 2, there is a slight difference. Okay, for ideal case, cos theta 1 equal to cos theta 2, we can ignore those two. Okay, V1 I1 equal to V2 I2. Now we know that V2 over V1 equal to N over 1 or N2 over N1. N is nothing but N2 over N1, or I can say I1 over I2. Okay, so when it comes to the P1, okay, V1 times I1, this is equal to P. Now when I look at the input impedance Zn, can I write this as a V1 over I1? Okay, I can write it as V1 over I1. Now I'm going to convert this into V2 over I2. So I can write it as V1 equal to V2 over N. Okay, at the same time I1 equal to N times I2. So when I write it down, V2 over N divided by N times I2. So Zn equal to V2 over I2 times N square. Okay, or you can say V2 over I2 times 1 over N square. So to find out the input impedance, all I need to do is transfer this, the secondary impedance, to the primary side. Okay, or you can say V2 over I2 is nothing but Z2, so Zn is nothing but Z2 over N square. Okay, so all I need to do is find the Z2, the total impedance on the secondary side, just divided by N square. Okay, here the self-inductance inductance of this coil is already included in the transformation ratio. Okay, here also dot convention is not going to come into the picture because you are doing the N square. So basically, if you have, in the same picture, if I need to transfer this to the primary side, okay, it will be V input. So this is how the circuit is going to look like. Vn R1 Okay, the reflected is going to be right here. That reflected impedance ZR equal to R2 over n square plus ZL over n square. Those two are in series, right? So this is how the circuit is going to look like. Now I'm going to solve a simple example based on this. So here is an example. In this example, he's asking us to find the power supplied by the source and power consumed in 18 ohm resistor. So our goal is I need to find the current here. I'm going to take this as I4. As long as I know I4, power consumed in resistor 18 ohms, I'm going to label that as P4. P4 equal to I4 square times 18. I square times RL, right? Based on that, that's how I wrote down that formula. Now, power supplied by the source. So if I know P is nothing but P equal to V times I times cos theta, right? As long as I have V, I have to know I and cos theta. This theta is nothing but angle between V and I. So I can find P based on that. Or I can say P equal to, if I take this current as I1 square times whatever the resistance here R total. Okay, total resistance connected to the source. As long as I know this, I can find the power supplied by the source. You can use the loop analysis, so mesh analysis. So assume this is I1 and I2, okay, and I4. Write down the loop equations. It's going to be a very long process. The short process is we just learned, remember, as long as it's ideal transformer and I know the turns ratio, I can transfer the load impedance to the primary side of the transformer. Okay, so that's what I'm going to do. So here, let me take this as ZL, that's ZL equal to 18 plus J 45 ohm. Okay, I'm going to transfer that on the primary side. So when we transfer that onto the primary side, either we indicate with the ZL prime, okay, or reflected impedance. I prefer to go with ZL prime. Okay, ZL prime equal to 18 plus J 45 over, what is n square? N equal to 3, in this case n square equal to 9. So which is 18 over 9, 2 plus J 45 over 9, 5. So 2 plus J 5 ohms. Now the circuit is going to be look like 6 ohms inductance. Okay, so how about this inductance of these coils? This is not going to come into the picture because it's already included in that transformer ratio. So I have 8 ohms minus J 20 ohms. 8 ohms minus J 20. Now I have ZL prime. ZL prime is the secondary impedance looking from transferring it to the primary side. Okay, secondary impedance of the coil transferring to the primary side of the coil. Okay, so here now we can eliminate that one transformer because it's already transferred. Now I can add these two. When I add them, the total is going to be 8 plus 2, 10 minus J 20 plus 5 minus J 15 ohm. That's the impedance there. Okay, now I have the coil ideal transformer. Okay, and resistance and reactance here. Okay, the first transformer ratio is given as 2:5. I forgot to write it down first. So here this is 2:5. Now I can transfer this to the primary side. When I transfer it, it's going to be ZL, I can write it down double prime, which is 10 minus J 15 over 5 by 2 square. Okay, so this value is 1.6 minus J 2.4 ohm. I have already 6 ohm and J 4 ohm. Okay, and the source voltage is 40 at an angle of 0. Now I can find the Z total or Z input, which is 6 plus J 4 plus 1.6 minus J 2.4. This will be 7.6 plus j 1.6. When I convert this into polar format, this is rectangular format in ohms. So when I convert that into polar format, that value is 7.76 at an angle of 11.88 ohm. Now I can find the current I, or I input current I equal to V over Z, which is 40 at an angle of 0 over 7.76 at an angle of 11.88. I have this current as 5.15 at an angle of minus 11.88 ampere. So here he's asking about what is the power supplied by the source. P equal to V times I times cos theta. I know V, which is 40 RMS value, must be I must be RMS value equal to 5.15. What is cos theta? Cos of angle between V and I. Okay, if I draw the vector diagram, here is my V, 40 at an angle of 0. I is right here, 5 at an angle of, I equal to 5.15. Angle is 11.88. Okay, what is the angle between voltage and current? Which is 11.88. Doesn't matter whether it is negative or positive, because cos of minus theta is cos theta. Okay, so that will give you the total power. This value is 201.58 watt. Okay, that's the power supplied by the source. So P source. Next question he asked about what is the he asked about what is the power consumed in the 18 ohm resistor. Okay, to do that I'm going to use the transformer ratio. Okay, so here I know this current is I1 equal to 5.15 at an angle of negative 11.18. Based on this, can I find I2? My I2, so I2 over I1 must be N1 over N2 based on the transformer ratio. Okay, so my I2 must be equal to 2 over 5 times I1, which is 5.15 at an angle of 11.18. Okay, here I'm not considering about the dot convention because my goal is finding the power, so that's the reason I didn't include the dots there. My goal is finding the power, so power is nothing but I square times R, so that's the reason I'm not taking the dot convention. It's not bad idea including dot convention, but I don't want to extend. It's already 13 minutes video. Okay, so this current I2, I end up with 2.06 at an angle of negative 11.88. Okay, now you can see 2:5. It's a step-up transformer. So primary has 2 turns, secondary has 5 turns. Okay, not exactly 5. If primary has 2 turns, then secondary will have 5 turns. If primary has 20, then this will be 50. So it's a step-up transformer. For step-up transformer, your N2 turns are larger than N1 turns. Okay, so a step-up transformer will step up the voltage, but at the same time, it is step down the current. Okay, so my I2 is 2.06 at an angle of minus 11.88. That's so it is current is stepping down, but at the same time voltage will step up. My goal is finding I3, okay, or I4. So here I have this current as 2.06 at an angle of negative 11.88. Okay, my goal is finding this current I4. I can write it as I4 over I2 equal to N1 over N2. Okay, so my I4 must be N1 1 over 3 times, this is also a step up transformer, so current is going to be step down, 1 over 3 times 2.06 at an angle of minus 11.88. Okay, so this I4 value is 0.686 at an angle of minus 11.88. Okay, now I need P4 power consumed there. Power is always consumed by the resistor only. Inductor does not consume any active power, which is 0.686 whole square times 18. That will give you the P4, which is 8.487 watt. Okay, as I mentioned, I didn't consider the dot convention here because I'm working on the power. But if I need you to find the current, for sure you should have consider the dot convention, because based on the dots the current might flow in different directions. So I better not to indicate the dots here. For sure, few examples in the future we're going to work with the dots. Okay, thank you.